One of the biggest factors in determining the value of a home is the square footage. The accompanying data represent the square footage and selling price in thousands of dollars for a random sample of homes for sale in a certain region. Square footage is going to influence the selling price. So that's our explanatory variable. We have here quite a few points. So I'm going to let StatCrunch help. Yes, it is available. And so to get the graph, we go to Stats, Regression, and Simple Linear. You can also do this with your TI-84, just that you're going to have to take the time to enter those points. So our graph is on the second, and it's increasing, but as we move left to right, it's becoming more spread out. We're seeing that in both B and C, but at a quick glance, I think it's C, and looking at the numbers, we're seeing as much as 4,000, which would not be included in B. So I'm checking out C, and my lab agrees. Find the linear correlation coefficients. So let's see here. That's on StatCrunch. We'll be back on that first window. We want R, not R squared. They want it rounded to 3 places, and a 0 in the 4th place would round that down. Notice that that is positive, going along with what seems to be a positive or increasing scatter diagram. Is there a linear relation? Well, we're not asked anything about critical values here, but 0.898 is kind of high, and we do have quite a few ordered pairs in our data set. So I'm going to hazard a guess to give linearity a chance and say yes. The regression equation that was also showing up in StatCrunch with the slope written second. They want this to 3 places, so that's going to round down. Remember, X was square footage. Square footage was our explanatory variable. Here's our slope. And then the y-coordinate of the y-intercept. That's going to round up 15.306. They're tricky. Slope to 3 decimal places, but the intercept to 1. So I should not be going on rounding I previously did. However, in this case, it's not going to make a difference because the y-coordinate of the y-intercept after the 1 decimal point in the hundredths place, we had a 0. So when we round to the nearest tenth, that's going to be 15.3. I didn't realize that they had different places to round to on these 2 different parts. Now it's good. Interpret the slope. That means for every 1 square foot more, the selling price, since this was in thousands of dollars, you multiply that 0.156 by 1,000, then it's going to go up by $0.156 thousand, i.e. $156 on average. and then interpreting the y-intercept. Although we have this equation, which 0 for x at a y-intercept, that would give us $15,300. So 15,300. Who's going to buy a house with 0 square feet? The house doesn't even exist. That would be out of the scope of the model and something ridiculous. So between the fact that it's outside of the scope of the model, that's an impossible house, and 0 would be out of the scope of the model. Look back here. Looking at the square footage, 0 is well outside of those values of x. All right, let's see what the next part is. One home that is 1445 square feet sold for $275,000. 1445. I'm going to plug that in. 0.156 times 1445 plus 15.3. This is a selling price in thousands of dollars. It's a 240.72. Home's price is the, okay, let's see. 240.72 is below 275. The average price of the home, that would be the 240.7. Oh, it's higher. 275 is higher than 240.72. If you saw the scatter plot and the regression equation at the same time, you see that line from the linear regression equation, least squares regression. This point would be above it, and you'd have a positive residual. Okay, that's all I've got. Have a good one. Stay safe and healthy.